Hi, welcome back to Mill Savvy Tutorials. I'm Luke and we're going to be continuing with our beginner's guide lesson 2. So in the first video we made this model, and in this video we're going to be applying toolpath to it. So first thing I did is, you'll obviously be a few steps behind me because I literally got in there and created these layers automatically, and I thought, well, I best click record. So create some layers, click the plus sign here, and look, there's nothing assigned to these layers at this point, but so we've got 10mm deep slot, and we've got a 10mm pocket, that wants to be 10mm deep pocket. Deburr lines, holes. This is where we're going to pull a lot of this data from. And we've got our stock that we haven't created, and surface machining, which I'll show you how to draw as well. So first of all, let's just assign everything we want to the right layers, and it's going to make programming this job super quick and super easy. So let's just turn the lines and holes that we kept from our modelling. So I want the 10mm deep pocket, so I'm just going to go up here and use the select chain of entities. Click there, click F3, so it grabs all of it. Go down to my layer tool down here, and I'll select that 10mm deep pocket. Click OK. It now moves it from that layer onto that layer. Turn that off. Now go 10mm deep slot. Grab the same tool. Select it, F3, move it over, turn it off, go to my holes, grab my holes. I'm just going to square this up, and grab all of that there, and then unselect the model. You see it's already selected all my holes for me, and then I'll move them over onto my hole layer, turn them off. So now all I've got left is this outside profile. So these are this is going to go onto my deburr lines, which is just here. So the only change that I want to make to this is I want to grab them lines just there as well. So let's just quickly grab them, and we'll do this over this layer here, and then we'll move them all. So I just want to grab that there. I want to trim them in, so grab that line and that line, grab that line and that line. Hold on a second, let's just delete these lines here. Go back, get your scissor tool. Well, one second, the reason this is doing this is because I need to project these lines onto the same plane, because at the moment, look, they're down here 0.25 lower. So if you go to your project tool, if you go into your square, go down here, project entities, go plane, click OK. Right click all of the ones that you find that you use a lot. These are the ones I use. There's not that many there, but I use these a lot when I'm doing stuff, so that's why I've right clicked them from down here. Look, if I right click that, it puts it up here. If I don't want it there, right click it again. They're already there, look. So you'll find you won't really access these options here. You'll mostly spend in your line, circle and scissors. So let's trim that in now. So let's grab that, click that, left click everything. You can see there, they're all my deburr lines. So let's just grab all of them, F3, move them over to my deburr lines, turn them off. So now all I've got left is that center point there. So I could actually just call this datum point. I could turn that off as well. So the only thing I've got open now is my model. So to draw me stock and surface machining, I'm going to have to do that now. So if we use my deburr lines, we can say that my stock for this example is 2mm on all sides. So let's draw that. So let's highlight stock. Let's go to my parallel line offset. And let's just say 2mm there. So let's parallel line offset that line there. Do the same there, do the same there. Now, I haven't extruded this line here, and I'll just show you another way. So the part's 100mm long in total. If I've offset this line by 2, the distance from there to there will be 102. So if I want 2mm the other side, it'll be 104. Alright. I could go down the path of extruding this line, projecting it, and using the parallel line, but there's no point. You might as well just you know what it is. Trim these in with trim 2 again. Alright, and there's your stock. Turn it off. Now your surface machining lines, so I'll draw them now So do the same if you're following me through on this. And I'll explain it when I come to applying the toolpath to why I've drawn it how I'm going to draw it. So what I'm going to do is extract an edge, grab that edge there, and I'm going to grab that edge there. I'm going to grab both of them, F3, F3, project them onto the plane, which will automatically put them onto this layer. So projection tool again, so you can either go this way to get to it, and there is another way you can get to it, which I'm not sure top of my head, but it's in here somewhere. I think you can get to it 2 different ways, but anyway, it's there. I've projected it up here, so click that and project it onto my plane. That'll move it on here. So if I just turn the model off now and my deburr lines, turn that back on so you can see what I'm doing. You want to regularly save this as you go through. All I'm going to do now is I'm going to use a 3mm tool to rough this out. So I'm just going to use my parallel line command again and offset this line. Sorry, offset all of them lines by 4. So if I just double click on the center of this line, you can see it grabs the whole lot, and then I can choose which side of the line I want to put it. So I'm going to put it on the inside like that, and then I can either delete this line because I don't actually want it for later, or I could just leave it there. It's not going to make a difference, but I'll delete it for the sake of this. Turn that off. So first things first, let's just quickly click save again. You want to regularly click save as you're going. So we want stock, because the first thing we're going to have to do is face this part. So let's go down to our toolpath, go facing, let's grab that stock, left click it, right click it, call in the tool that you want to use. This is the tool that's loaded in, so 63mm face mill. If you want to change it, go into your library, go facing, pick the face mill that you want to use. So all this looks fine. I'll run out of this. Start and finish clearances, I always go Z20, then come into Z2. But what we can say is, look, there's 3mm material on that top face, so we want a clearance of 2mm above the stock, so we'll go 5mm. The material top is 3mm, and we're going to machine it down to 0.2. So this is your amount. So for instance, if that job was 100mm wide, and I'm using a 63mm face mill, it's going to step over 75% of the tool, so my step over distance will be 47.25 if I'm doing a zigzag style step over. You can do spiral, one direction. I pretty much use zigzag for everything, because you'll find if you, for instance, like I'll show you something here. If you do this, you can see it's going to zigzag like this, but it's a little trick here. We know that the tool is big enough to do this in one sweep, so I'm just going to change this to 90%, and we know that the part is 54mm with the stock is 54mm wide, and that way it just cut on centre line like that. So it's going to save me a lot of time. It's just going to do one sweep, clean everything up in one go. There's no point doing 3 step overs when you don't have to. So we're going to duplicate that, and now I'm just going to go in, right click and edit it. I'll slow the feed rate down, keep the plunge the same, because it's not going to cut when I'm plunging. Set that to 0, the Z top's now 0.2, and I can now set that at 2mm as well. Click next, click finish, there it is. So I'll face the top. Now what we're going to do is, I'm just going to create one more layer called profile. And we're going to grab that profile from the bottom face because it's easier. There's no point grabbing it from the top because it's going to want to go around here, and that's not what I want. So let's extract the lines from the bottom face. Let's go to extraction tools, just grab these edges here, like that. Just left click in all that, then grab all of it. You'll find I use this pretty much for everything. Right click, and we will project them lines onto our plane, which will automatically move them to our profile. There they are. Now we've got all the information we need to tell OneCNC that we want to machine all of this material away up to that profile. It's super easy. Just go into your toolpaths down here, go high speed pocket. I know we're profiling the job, but this is where you can use high speed pocket for multiple different things. So let's click here. If you read at the bottom, it says select the first close or open boundary. This is going to be our first boundary, and then basically it says select any like boundaries or islands. So this is going to be potentially an island. So you click that again, so left click, right click to go into your toolpath. Let's find a tool capable of doing what we want. So let's find a 16mm carbide end mill. We'll call this tool 2, and we'll spin it at 10,000. That'd be number 1 here, by the way. I've just renamed it to M08. G54, go 2,500, yeah, 3,000 actually. 2,500 plunge feed. Remember, I won't plunge cut nothing, so that's why my plunge feed is a bit excessive. You know, we're not going to actually plunge cut, and I'll show you why. So Z top's now 0. We want to go minus 21. Part's going to finish at 20mm thick. We want high speed open, and what high speed open basically means is the first boundary that we select, we're basically telling it that everything outside of that boundary is free space. There's nothing out there the tool can, you know, come in and plunge down, and it's not going to touch anything on this side of the line. Closed is the opposite. You're basically telling it to stay inside of that line, but then you have to obviously either select somewhere where it's safe to plunge down, like a through hole or something, or if there's nowhere safe to plunge down, like in this pocket for instance, then you just pick a different style and you go heli ramp down, basically you ramp helix or zigzag down. So I want plunge, and we'll do a step over of, we'll do 1mm just so you can see it a bit more in the simulation. We don't want any rough depths, we'll go straight to finish depth. We're going to leave 0.2 on the sides, so we'll click finish. You can see it's done all that for me. It's a good time to click save again. Now what we're going to do is we're going to finish profile that. So let's go to our mill profile tool. Let's grab as close to the end of this radius as we can. That'll do. We want to pick that side of the line because we're not going to cut this side of it, are we? So let's go that side. And let's click F3 to go all the way around, and then right click. We need the same tool, so tool change. That wasn't the tool that I thought I clicked on. I thought I clicked on a 16, but we used the 12 then. Fine. Finish 1500, 2500 plunge, Z minus 21. No cut levels. Doesn't matter about step over because we're not going to leave anything on, and we're not telling it there's a remove amount. So this directly relates to this on profile. If I put 10mm and put 1, then it's going to step over 10 times 1mm at a time. Turn that off. I want that set to 0. Click next. I want it to use comp to finish it. So I'm going to put at the bottom, finishing bottom only, compensation at control. That'll be your G41. Click next, and now this is where this is a tiny bit misleading because you've got line and arc, but if I just put 10, 5, 10, and then basically take these values and put them down here, that's what these 3 arrows do. Look, click them and it moves them there. So I've got a 10mm line coming on at 5 degrees and a 10mm line coming off at 5 degrees. So you've got the gradual in and out. So if you just zoom out and show you what that looks like, you see there, look, there's your 5 degree line, 10mm long, comes in, goes round, goes all the way around, comes off, and then comes off at a gradual angle. That way you don't get that dwell line that you see when you comp on and off of parts. It just phases in nice, and it's starting off the job, which is another thing to point out, which you get with a lot of CAD CAM. You see people just start in the middle of a part, go around and come off. Yeah, they might arc on and arc off, but you're still going to get that on and off mark, which I don't like to see anyway. So again, you'll see that I'm pretty much going to save it after everything I do. I've had too many things lost to the lack of saving, so we'll do it as we go. Right, what we'll do now is we faced it, we profiled it. Let's do the pockets. So let's turn both pockets on. Let's turn off the stop now. Let's turn off the profile. We might redraw this one, and I'll show you why in a minute, but let's do this pocket first. We'll do them in 2 different ways. So I'm going to high speed pocket. We're going to select that pocket. So left click, right click. Let's grab a tool. I'll tell you what we're going to do. We're going to grab a big tool nut, and then I'll show you 2 different ways. So this, we use the 12. No, we're not. We're going to go even bigger than that. We're going to use the 16. So it's purposely not going to be able to finish them corners because they're 8mm rads, I believe, or 6mm rads. 6mm rads. That's it. Because this would do an 8mm rad. So let's go tool 2. Let's go 10,000. G54 feed rate. We're going to go 2,000. We'll leave that at 1,000. 0, yeah, minus, we're going 9.8. High speed close now. We want a helix ramp down. We haven't got a hole to select an entry point, so we're going to leave this as automatic. I always have this set to 16, or, well, not 16, but whatever the max is, because I like that tool to move as much as possible when it's ramping down. If you're trying to put a 16mm tool down a 17mm hole, it's not, you know, I mean, it's going to struggle to get that swarf out of the hole. It will do it, but it depends on what feeds and speeds you're using. Point 2, we're going to leave on the wall. We're going to set our step over to 2mm. Actually, we'll leave it to 1. Leave it to 1, just to show the step over a bit more. We don't want to finish it, so let's click finish. You can see there, look. But this is another thing, so I'll show you. So that's going to rough this pocket out, but it will probably leave a little bit of material in these corners where the tool physically can't get in there. So this is where you use high speed pocket again. Click it, and let's grab a tool that can finish it. So what we'll do is, we won't use a 12, we'll use an 8mm, because I can use an 8mm to do the other one as well. Let's find an 8mm carbide end mill. Click that. We'll call that tool 4. Set 10,000. I'll go 2,000 on there, 1,000 on there. We'll keep this at 9.8 for now. High speed close, and now you want to click, look, rest machine, and you want to select that pocket 5. And now it's going to search for everything that hasn't been finished from the 16mm tool. We're going to go ramp helix. One thing we are going to do though is we're going to go right back to the start, and our material top is at 9.8, but we'll leave it at 9, so it doesn't sort of, you know, plunge at that feed rate down to 9.8. It's going to heli mill down at from 9 to 9.8. Go a bit more. Flick through all this. This all looks fine. I'll just step over it. Go 3. Leave point 2 on it. We don't want to finish just yet. Click finish, and you see, look, it just goes into the corners which the 16mm couldn't finish. I'm just going to go into here and edit this 16mm because I called it tool 2 by mistake. We'll call it tool 5. Just go through there because I've already got a 2 tool up here. Look, that's tool 2. That's tool 2. You can. Let me increase the size of this. If I click on here, this will give you data on what tool you're using, what offset it's got, what datum you've used, stuff like that. And then same for this. Look, I always do a quick flick down here before I go posting anything out, just to make sure. And obviously, I'll watch the simulation really closely, make sure there's any changes that need to be made. So we've now roughed this, gone in there with the 8mm and just roughed out the extra bits. Now what I'm going to do is I'll just high speed pocket again, and I'm going to change. I'll keep all this the same. I'm now going to change this to Z-10. I'll leave that at 9. It's not going to hurt. And I'm going to change to traditional style milling. You normally get the best surface finish in a pocket doing that sort of style. Leave that. Leave this. Click next. I'll increase my step over up to 6. And I am going to leave this at 0.2, and the reason being is it finishes the bottom before it finishes the sides. So I don't want to go, as I'm moving across and changing direction, I don't want to be going onto my finish size pocket and leaving that change of direction mark that you'll see. So, and I'll go bottom only, at control for comp. Same here, I'll leave these at 90. It's a bit safer when you're using a pocket because you can't pick where it comps off. It picks itself. So what you don't want to do is say comp off here, go at a 5 degree angle and just go into the wall. So the 90 degree will make sure it's always coming off in a safe place like this. So rough, sort of rough again, finish everything. Now we'll do this slot here. So what I'm going to do for this, I'm just going to redraw this, 10mm deep slot, click my face, double click my space bar. I want to make sure that what I've got here is able to get an 8mm tool in there. Now I can select my start position. So I'm just going to put a line there, get rid of that. Trim them in. Undo that. I need to give myself a line. Draw up to there. I want to parallel line this. I want to come back 4.5. I'm just going to put a circle in the middle of that, which is 8.5. Click it on there where it snaps to the center. Just grab that line and delete it. And then I'm going to use my fillet command and put some 6mm fillets on here. Right, so now we've got our slot, we've got our entrance point, which is safe to plunge down because there's nothing underneath it. Go back to our plane, another time to click save. Now we're going to use a high-speed pocket again in here. So let's go back into here, a high-speed pocket. We're going to grab that. Left click, right click, grab out our 8mm tool in tool 4, it remembers everything here for us, we use that again. Go down here, we want to go, so we're going to put that back to 0, we want to go to 10mm, but we're going to set that to 9.8. I'm going to go traditional, I'm going to go plunge, select my entrance point, step over distance. At this point it's not really, it's irrelevant because the tools can naturally, it's 8mm going into a 12mm slot, and I'm going to traditional style mill it, so I'm going to rough depth, use the rough depth command. So I'm going to leave that at 6. It's only going to do a maximum of what it can. So let's set this to, so it's 9.8. Let's divide that by 3. And then we've got 3.267. So it's going to do 3 step downs. We're going to leave 0.2 on the sides. Go next. We don't want to finish, so we'll click none. Click finish. Grab that point where you want to start. See at the bottom it says select circle for entrance start point. So left click there, right click. And that ain't going to mess around. That's literally going to go down, round, down, round, down, round. Now what I'm going to do, go back to my top view again. I'm going to grab my mill profile tool. I'm going to grab that there like that. Come on the inside line. And then I want to end here. So I click there, grab my 8mm tool again, happy with this, finish it at 1000, keep out of that. I don't want to go 21mm deep though, I want to go -10. Try again, Luke. There you go, -10. All this looks good. Cut levels, nope. I don't want to ramp, I just want to go straight down to 10mm and finish it. Nothing on the sides. I've got nothing to remove other than the 0.2. Well, I'm not worried about that. I don't want. So that's irrelevant because that talks to this. I don't want to leave anything on. I want to finish it. I want to use G41. Click next. I can leave this at 10 and 10, but there's no point. I may as well change them to 5. I'm just going to waste time moving further away in fresh air. There you go. You got your angle on. You go around. Your angle off. So now we'll come in, we've finished the pocket, and we've finished this slot. Now what we'll do is we'll countersink these and drill them through, and then we'll deburr the profile, and we'll rough and surface machine this out. So let's click save again. So what we'll do now, let's use our drill hole wizard. So let's turn this off, turn the holes on, go down here, drill hole wizard. It's a good tool this. It'll find all our holes for us. Turn them all on. This all looks good. 20mm, then 2mm, 2mm. Yeah, top of our job's 0. Let's click center, click drill, double click into your center drill with your left click. I'm going to use a 8mm spot because I've got a 6mm countersink. Speeds and feeds look fine. Click next. Go 3mm deep to create a 6mm countersink. Remember, yours naturally will probably be on automatic drilling or something like that. Click machine cycles. Click next, and then pick the machine cycle that you want, which is obviously for this would be a G81. I always leave this in G98. It's safer to use G98. I can talk about G99 and the benefits to using it, but at this point it's not really important. Click finish. Go into your drill. Double click on there. Tell it what drill I want to use. Use a 4.5mm drill. If you haven't, go into your library, go drill. If you haven't got a 4.5mm drill, click edit, clone something. I'll tell you what, I'll do it just to show you. Let's clone this and put a 455 drill. So if I've got that selected, go clone, it goes to the bottom. Delete that, let's call it a 455 drill. And then you go to your diameter column. And we'll call that 455 drill. And everything else is going to be pretty much the same. You can go in here and change your holder if you want. And then look, you can see what you've got here, and you've got your stick outs and everything. You've got your flute length and how far it's sticking out. So you set this up so this matches what your machine's using, all right? And then that way your simulation will match your real, the real sim. So anyway, I don't want a 4.55, do I? So let's grab the 4.5 again. Click OK. Let's go. So what is it? We're tool 6. So I do 318 times 50. Gives me 15,900, and then I divide that by my drill diameter. So divide by 4.5. That's my speed. That's aluminium speeds and feeds, by the way. And then I will get 353, and I'll times that by 0.08. These are quite bog standard speeds and feeds. Your drill will run harder than this, don't get me wrong, but these are quite safe for various different things you'll be using it for. It's just a good sort of speed, like good generalized speeds and feeds. So I want to go, so look, this is quite handy. If we go 20mm, it'll tell me how deep that drill needs to go through. So it says 21.3, let's go 22. Machine cycle, next, G83, we'll do 5mm pecs, click finish, spot, drill. It's done that. You see we're starting to build up a bit of history here. Let's click save again. So now all we've got left to do is deburr everything and then do a surface machining around here. So let's go on our deburr lines. And we wanted a 0.25 break edge. So I use comp when I deburr on here. Some people don't. They go into like their deburr command down here and just literally grab all the available lines and deburr. It's a powerful tool, but I find that your deburr with this won't be as nice as what you get when you do use comp. Plus, by using comp, you're giving the guys a little bit more control of the machine. So let's come on here, and I could do this again, or I could go up to. No, I will because it's slightly different to our profile. I was sort of trying to skim ahead there. So mill profile basic. Let's do the same thing we did earlier for our tool 2. Click that side of the line again, let's click F3, and you'll see it's now grabbed all the way around here. Right click, let's grab my 3mm spot, go down to my spot drill, and what I have here is a 3mm spot with a 1mm offset. Let me just edit that gap there. Okay. So what I've done here to use comp with a tool like a 3mm spot and get it to work properly on OneCNC is I've basically manipulated this 3mm spot, and it believes it's a 2 diameter tool because I've put 1mm offset. So this is what I want the operator to set the tool at. I want a 1mm offset because obviously we set everything, where the companies that I do work for, they use radius as their offset rather than diameter. So I've asked them, I want them to put a 1mm offset in their radius column. So that's why, and I've modelled this tool to 2mm, and I've said what it is here. That's my way of getting round using sort of comp on CAD basically. So let's spin it at 10 grand. G54, a feed of 1,000, plunge, It's not going to do anything in plunge, so speed that right up because we don't want to be moving real slow when we're in fresh air. Z20, Z2, Z2, material top is 0, and we don't want to go -10, do we? We want to go 1.25, and the reason we go 1.25 deep is if you've got a 1 mil offset and you go 1 mil deep, you're going to potentially get a slight break edge. So if you go 1.25, you're going to get a 0.25 chamfer like this asks for. Click next. Yeah, that's fine. Yeah, all this looks good. I don't want to, if I left anything on there, it wouldn't work. Bottom only, at control. Leave, yeah, all this looks good. Click finish. There you go, comes on, goes round, chamfers everything and comes off. So let's click save. So now what we're going to do is we're going to go into our surface machining lines here. Let's turn everything else off. And what we're going to do is we're going to go into our surface machining options here. There is a lot of options in OneCNC, and all of these are good for their own reasons and different applications. You'll find a lot of the time that you'll find ones that you like the best. For instance, area machining is great. It's super easy. It literally does, look, if I just grab that, look, it just grabs it and surface machines it for me. But I'm going to use 2 just to show the difference between 2. I want to use Z level finish because that will follow that contour all the way around, where some of them will only go like in a straight line like that, and that wouldn't be the most time efficient way of roughing this out. So yeah, let's use tool 25, 10 grand again, G54, 1500, yeah, this all looks fine. 3 mil tool. Yep, that looks fine. Click next on there, and I'm going to ramp on my boundary. Means while I'm going round, I'm going to be ramping down rather than plunge cutting. Click next on there. Depth of cut, we're going to 0.25. It's only a 1 mil rad, remember, so I'm only going to step down about 4 times. Leave 0.1 finish. Leave that at none, that's fine. I'm going to pick my boundary and I want to stay inside of it. I've got a Z top of 0 and a Z bottom of -1. Click finish. So grab your first outside boundary and then grab your inside boundary. Left click, and then click right click. You can see there, look. So it's roughed it out. And now I'm going to use my area machining. And this is where I love area machining because it's super easy to use. You just select everything you want it to surface machine. It does all the hard work for you. You don't have to draw any boundaries, you don't have to tell it anything, you just grab it off the model. I could surface machine this chamfer here if I wanted to. So right click now, once you've selected everything you want it to do, let's grab a tool a bit more suitable rather than a great big ball nose. Let's use this 2 mil ball nose. We'll call this tool 7. Spin that at 10,000. Don't get me wrong, aluminium speeds for feeds, you don't really have to be that clever. You just spin everything fast and move everything at a sort of a fair feed rate. A lot of these tools that I've used for years, so I know what you sort of spin them at. Obviously, if you want to fine tune your programs, then you want to have the cutting data up as you're doing them and get the data from the appropriate places. So any feed rate, we're going to go feed rate 600 on there. I'll leave the plunge rate. I'm going to put it 500. I shouldn't do any plunge cutting, but let's go 20. Z2, plunge clearance 1. That's fine. Step over. I'll go 0.2. Leave finishing 0. Yep, click finish. That's simple. Click save. What we'll do is we'll just turn our stock on quickly and we'll just simulate our op 10, and then I'll show you how to flip it over and do your op 20. So Z top 3, Z bottom -25, click that, and that was picking a boundary. That was the option there, so left click that, right click. So let me restart that, look, cut, finish. So we'll speed this up. So that's our 12 mil tool there. If you're trying to look at something real close up and this is in your way, then just turn your holder off. You want to get rid of it completely, turn it all the way off. I like to have everything sort of transparent like that. Same for my tool really. You can do the same here, look, tool, turn tool off if you want. I do quite like to see what the tool's doing though, so anyway, let's slow this down so I can show you what it's doing. So you see it heli ramp down. and then it's going to try and get as close into them corners as that tool physically can. And then you'll see the 8mm come in a minute, and it's just going to literally look, just nibble that out, and it's going to come in, really ramp down, and now it's using that traditional style milling to do that bottom finish. No messing around, 6mm step over, come on, comp on, go around the wall, come off. That's going to leave you a lovely finish in that pocket. And then look, we're coming in here and sort of slotting in. It's going to be quite time efficient. Good way of removing material there, and then comping on and going around. That finishes the side and the bottom at the same time. Now we'll spot all these. Drill them all, speed that up. Come on a deburr. Now it's not going to simulate the chamfer exactly how you'd expect to see it. There's the one thing you do have to sort of compromise on a little bit, but you know if you've got your depth and your offset right, you're going to get that chamfer. So rough it out, and then the ball nose is going to come in and finish that 1mm radius, 1mm fillet. Speed that up a little bit. Cool, hang in there, PC. There you go. Once we've got that, as a little check, we'll just rest machine it, click OK, and this is comparing what we've machined to our model. So you know this little bit of yellow around here, that's obviously where it's not going to simulate the break edge, because obviously I've cheated it by saying it's a 2mm tool when it's actually a 3, so that would make up the difference and it would cut. These lines that you see here is where I've sped my simulation up, and my graphics card can't physically produce a smooth line when I'm running it that fast. If I was to run this graphics a lot slower, you'll find that these lines and stuff like that, they wouldn't be there. It all depends on how good your PC is, really. So I can see, look, I've finished everything other than removing the back. So what we're going to do, we'll do that now. Let's click save. What we're going to do now, we'll move this down a little bit, create ourselves some space. We're going to create a new group, and then we're going to set that to our active group. And now what we're going to do is we're going to create a plane on the back. I'm going to put that datum point on and turn everything else off. So we'll go down to our create a plane, create a plane from a surface. Let's grab that. I'm just going to grab that point just down there, and I'm going to project it up onto that plane. It's not going to move it in the X and Y or anything like that. It's just I want to make sure my plane is positioned properly, because this will be my G55 datum. So I'm just now going to position my plane from a point, and now I can move it. So even though it looks like it was central, don't assume it's central. Because if it's not, you're gonna get it wrong. And if you're a little bit out, all you're gonna see is you're gonna gouge in with your chamfer on the back face, and you'll scrap the path. So don't assume nothing. Come in and double check it. Do it the same every time, and you're gonna get a good result every time. So let's save that now. We'll call that G55 plane. Now all of our lines are already there. Our profile's there. Our facing lines are there, our whole lines are there. We can literally do everything from our lines. Even though they're at the bottom, it doesn't matter. So let's go back into our toolpath, go facing, let's grab that, left click, right click. Now the only difference is we're going to have to call this G55 now, because when we post this out we want it to be suitable for someone to do a 2x set. So we're 25, parts going to be 20, so there's 3mm on the top, 25 underneath. Yeah, so we've got 5mm on the top there, so let's just call that, let's just say that's, let's say 7, so we're clear. So that's 5, we'll rough it down to Z2, and I will use rough depth, so we'll set to 2. We'll keep this the same, increase that back up to 90 again, click finish, and it's going to go 2 more deep, rough it, leaving 0.2 on it, then we'll put a finish pass in there as well. So let's duplicate this, go into edit, like we did last time on the Op10, keep all this the same, yep, no problem. I'll slow that down I guess. Set that to 0, set that to 2, set that to 2, sorry, set that to 0.2, turn rough depths off, yep, that's fine, click finish. Now all we've got to do is deburr and spot the holes. So let's use our, we don't want the deburr lines because they're different to this face, we're going to use our profile lines. We'll come in with that tool that we just used, the 3mm spot, grab that down there, go that side like that, click F3. Yep, all looks good apart from the G54, click G55. I haven't modelled a chamfer here, so we'll do it as it says. We'll go 1mm deep, that's just a break edge. Yep, all looks good, that looks good, yep, fine, yeah, that'll work. And you can see, look, even though I'm selecting these lines, it's putting them up here where my plane is set to. Click save, let's turn our holes on, let's turn the profile off, let's turn the stock off. Turn that off. Right, so the holes are down here, doesn't matter. Drill our wizard, let's grab them holes. All this is fine. Grab our center drill, double click into our center drill, change that to G55. It's going to remember everything we've used from G54. So look, 3mm the same, but there is no countersink this side. So let's go 2.25 for half or 4.5. Click finish, click save. Now what we'll do is we'll go back up to here, make this our active group. We'll now go select our original plane, go back to our default plane, double click your spacebar, bring that back round, spacebar, click default view, and now we'll right click that and we'll simulate all. So that's going to simulate both groups. Click simulate, all this looks fine. Pick a boundary. Oh, before I do that, I need to turn my stock back on. Simulate all. Okay. Grab the stock. Left click, right click. Now I can watch it all the way through. I have to find some music when I edit this video, so you've got something to listen to while this is simulating. Speed it up so it's not so boring. Obviously we've all seen this once already. Come in, deburr, rough that out, see how quick that does that, and then surface machine it. The bigger the step over, the quicker it's going to be. In all fairness, I've done a lot of stuff at 0.3 and that tends to look okay most of the time. So when you want that really good finish, you might have to reduce it right down to about 0.1. But to be honest, a 0.2 step over normally gives you a pretty good surface finish when you're surface machining. Again, when you've got your simulation sped up, your graphics isn't always going to look that pretty. So the slower you run this, the more accurate this will look. Just bear that in mind. So now it's going to flip over. I'll explain, I'll touch on it on the flip in a minute, so you can see there, faces it off, comes in, deburrs it, and then spots all them holes. This would be orientated like that in your vise, because that's how we programmed it in that view. So you can see it simulated everything. Let's just quickly click rest and just check everything looks good. Look, grey everywhere. That's what we want to see. Take your time to really have a look at your rest machine like projection, because this is where you capture all the stuff that you missed on complex parts, and it helps me out massively when I'm doing like 5-axis parts and there's loads of intricate little bits. I mean, this is a very basic part, but you will miss stuff. I mean, you know, you're working your way through the model and you're trying to cover everything, and when you're doing like, you know, you've got 100 different tool paths, you know, you might have forgot to finish something. So this is why this is good. Again, you're going to see a little bit yellow here because obviously my simulation sped right up. But anything like this is fine. You can see because it's mostly grey. But anyway, once you've had a look at that and you're happy with it, great. Click save. Not close. Click save. And the reason this simulates all the way through and rotates for me is because I have reposition selected. I have this set as default. So make sure you've got 3-axis reposition on when you're simulating something all the way through. So in the next video I'll talk about setting up your groups and what to call them, and then we'll also go into the post and how it comes out and how you change your post here and you know how you want it to look, how I filled this out and the data that it kicks out for me when I post it. We can even talk about job sheets. You can preview it. Obviously your job sheet will give you a rough cycle time. I haven't even opened this yet since I bought this software, but yeah, so it's good. So thanks for watching, and I'll see you in the next video. Cheers.